Hey guys, this is Terrence. Welcome to the first episode of an Architect's Processing Notebook. Today's video is about the grid. The grid is the most fundamental pattern we encountered in our early days of study, and it's a very useful pattern. We can use it to lay out columns, to lay out floor plans, and we can use it to do the facade design, I think. And actually, this pattern has a lot of potentials to creating some amazing variants or amazing designs. And today I'm going to show you one of the variants created by the grid. So why don't we get started? And let me first bring up the process of generating this pattern. The first step is to define how many points we want to scatter along the x-axis and how many points we want to scatter along the y-axis. Based on those numbers, we can calculate the x spacing and the y spacing between each points. And we have the points, we can use the points to draw the rectangles, but actually we don't need to show those points. We just make those points run in background. And then the third step, we can shade or we can paint those rectangles. The color mode I want to use here is HSB, which represents the hue, saturation, and brightness. I think it's very handy mode. It's a very handy color mode. Then after painting those rectangles, we can create void inside each of the rectangle. And the last step is to use shear functions, or we can say we can shear those metrics to create some dynamic lookings. So I think we can start coding. I will put this aside as a reference of each of our steps. Okay, first, we need to set up the basic environment. I can say void set up. I can define the size of the canvas as 800 by 800. And the following function is to draw the pattern. And our first step is to define the number of points along both axes. So I can say integer x number equals to maybe 10 for now. Integer y number equals to 10 as well. And here first, let's calculate the x spacing and y spacing between each points. We can say float x step equals to float width divided by float x number, because I want to get a float result. So I need to wrap these two values into a float function. I will do the same thing on y-axis. Float height divided by float y number. And we got these two values. Now we can loop over both numbers. We can loop over x number and y number to create what we call points. I can say for integer I in range. Oh, sorry, it's a Python way of writing. I can't do this here. I equals to 0. When I is smaller than x number, I plus plus, then we created a nested loop. We can say integer j equals to 0, j smaller than y number, and j plus plus. Then we can say we can find the x position and y position of each point. Then we can say float x position equals to I multiplied by x step, and y position equals to it should be j multiplied by y step. And I think we can start draw rectangles here. I can say rect. I want to use another method called matrix because this will be easier for us to share the matrix afterwards. So I will say push matrix, push matrix here, then with a pop matrix at the end. Inside here, I want to first translate the origin of the matrix to each point's position. So inside this parenthesis, I can say translate x position, and translate to y position. Then I can draw a rectangle here with 0, 0, and the width is x step. The height is y step. I save the code and run it to check the result. I will bring this here, bring this back, and it seems our code is correct for now. Then the next step is to shade these rectangles, or to paint these rectangles. So we need to set up the color mode here. We can say color mode. Color mode is HSB with a maximum value of each one, 360, 100, and 100. And we can say our background can be 320. I don't want it a completely pale background. I want it have some shades, so I choose 320 instead of 360. Then inside here, maybe I can create some variables represent each of these three values. I can create a hue, a saturation, and a brightness separately. I can say float. Oh, it shouldn't be down here. I can do this here. Float hue equals to my preference is to limit this color in a small range, so the color won't looks won't looks too colorful or too dynamic. So what I did is 160 plus random 150. So I limit the range of the hue between 170 and 320, I think. Yes, 320. I limit the hue inside this range. Then I can create the variable represents the saturation, which equals to 50 plus random 30, and the saturation ranges from 50 to 80, and the last value is the brightness. I can say bright equals to 70 plus random 30. Then I can say fill hue, saturation, and brightness. And also I don't want hue here. I don't want the shape has strokes. That's kind of destructive. So I can say no stroke here. Save the code and run it. Wow, it's changing all the time. It's not something we want. So we want to set a random seed to make this graphic static instead of blinking and blinking. Yeah. So here I can say, I can create a random seed here. I can say integer r seed equals to 100, and maybe down here, where it is, maybe down here, I can say random seed. Inside here, we put the R seed we just created. Let's save the code to check. Yes, now we have a static image instead of a dynamic one. Then let me see. Oh yes, we still need an alpha value. Alpha value is kind of opacity. So we can create the alpha value here. I can say float alpha equals to 30 plus random 50. Sorry, 50, and I can how to say, I can reframe this part a little bit. I can say color fill color equals to color hue, saturation, and brightness. Then here I will replace these three values with this fill color variable and alpha value. And let's see the result. Okay, it looks not that vibrant now. I think we can try to add control on random seed, so we can choose what kind of combination, what kind of color combination we prefer, instead of we adjust the R seed here every time. So down here I want to create a new function, or I want to use the built-in function, which is called mouse wheel. Mouse wheel means when you're scrolling your mouse or when you're scrolling on your trackpad, there will be something happened. What things will be happening just inside? Sorry, I mean we can define what events happen inside this function, and I want to say inside this function, when the mouse wheel runs or when we are sliding on the trackpad, the R seed changes. R seed equals to a random value between 0 and 1000. And save the code. Let's check the result. It should be a float. Can I change this to float? Oh no, it can't be work in this way. So I should wrap this random value inside an integer function. Save the code, run it, and now you can see this is static. When my fingers moving on the trackpad, the pattern changes, or the color combination changes. Then we can choose a specific kind of pattern we want. So I think we finished this part. Then the next step is going to be create void inside each of the rectangles. So what I want to do is to create another rectangle inside the rectangle, but that rectangle will shade as white. So here I want to say I want to create another rectangle. First, I need to define the color. I can say fill. Color could be the same as background. I define here it is 320. Then we draw another rectangle here, but there's a little computation here to define the start point, the void start point. It's a little bit shift inside the rectangle, and I set the value as x step divided by 4, y step divided by 4 as well. Then the width of the void could be x step divided by 2, and the height could be y step by 2. I think this works. Save it, and okay, you can see we have the voids, we have our rectangles, and each rectangle were shaded or painted. Let's see what's our next step. Oh yeah, the next step is to shear this matrix to this form or transform this form these rectangles according to the shear value we provided. So I want to say where I can change here. I can say translate. Yeah, I can do this here. I can say shear x, the EAR, sorry, misspelling here, x equals to random 1 multiplied by pi divided by 10 minus pi divided by 20. I tested a lot of number combinations, so I think this value can help us generate a gentle deformation. If you guys want to make things more radical, you can change the value here. And this line of code will generate a random number ranges between, let me see, ranges between minus pi divided by 10 to positive pi divided by 10. Sorry, let me rephrase this a little bit. This part of code helps us generate a random value ranges from a negative pi divided by 10 to a positive pi divided by 10. And we will do the same thing on the y-axis. We just need to change this from x to y, I think. Then save the code, run it. Yeah, we deform it. The next step is we want the void, the deformation of the void slightly different from the deformation of the rectangle itself. So we can copy these two lines of code, paste them here, and maybe we can change this value a little bit, make it looks pretty different. We can say pi divided by 8, and here could be the 16, sorry. I can change this and run the code. Yeah, this is pretty much close to what we want. But you can see the angle is still too acute. We can also add some fillet at each corner. So the code we need to modify are these two lines. And you know, the rectangle function, in the rectangle function, the first input is the x position, then y position, then width, then the height. And also we can add more inputs to adjust its fillets in each corner. If we just input one fillet number, that will apply to all the corners. That will apply a fillet to all the corners. And we can do this, we can modify this as 10 multiplied by random 10. So the fillet value will ranges from 10 to 20. And here for the voids, we can make the value much smaller. We can say 5 plus random 5. Yeah. And save the code, run it. Bow, and I think we just finished today's pattern. But it looks still too much opacity here. I think we can increase the opacity here. I think we can make it 50 to 100 maybe. Not much change, but it's apparently much more clear than before. And when we scroll, the pattern changes. So I think that's it for today's pattern. This series of video are gonna be very lighted, very easy to follow. So that's it for today's pattern. Thanks for watching, and if you guys have any questions, any critiques, or any comments, please let me know. And I will put the code into my GitHub repository, and I will put the link in the introduction of this video. You guys can find it there. And thanks for your time. Bye bye. Yeah.